we start, guys. Are you ready to pay attention? Okay, so now the topic we are discussing now is extremely important and extremely easy. It is about partial fraction decomposition. Fraction this is super useful in Cal 2. In Cal 2, I suppose the majority of you need to take Cal 2, no? Calculus 2. Okay, and of course the teacher can explain Calculus 2 again, recap that part, but no, it's important that you see at least one time in pre-calculus. What is the idea behind partial fraction decomposition? When you have a rational function, remember rational function is polynomial divided by polynomial, right? And the classical p of x divided by q of x. And I suppose, one more thing, I suppose that the degree of the numerator is less than degree of the numerator. So degree of the p is less than the degree of q. When this situation happens, this rational function is called proper. Otherwise, if the degree of the top is bigger, it's improper. And when it's improper, you apply long division. No scientific division because you don't know si the degree of the q is 1 degree. Si es degree 1, we can apply scientific division, but si it's no 1, you apply long division that's more general. And you convert division, and you convert somehow in a proper fraction. Because you know, when you divide, the remainder is the degree less than 1 the divisor. Entonces now you automatically, you apply, okay, you verify our rational function is proper or improper. It's improper, long division. And you immediately, you take the remaining part and you convert it to the proper. Now, I suppose now que es proper. What's the goal? Well, the goal is convert or decompose in partial fraction. What is the partial fraction? We have two kinds of partial fraction. The classical partial fraction we need to decompose any rational function is this kind, que es a number. Let me copy no letters, a number. Suppose 20, arbitrary number, x minus 2 or negative 40, x plus 5. Now this is a classical partial fraction. In this partial fraction, you have in the numerator, we have polynomial degree 0. In the denominator, you have polynomial degree 1, linear. Okay, this is the most popular. We have another. It is when you, for example, in the bottom, we have the Professor Ryan from the class say no power. Okay. Any issue que es no mathematics, guy, you email me, you inform me by email. Yeah, I reply. But not here, you interrupt me, no? Okay, now this is the first kind of partial fraction. The second kind of the partial fraction is when you have irreducible quadratic expression, for example. Okay, you know the factorization is imaginary or complex. No? So in the numerator, we have maybe linear, 2x plus 3. In this case, the degree of the numerator is 1, and the degree of the denominator is 2. This is the idea. Let's see example to understand more clearly this idea. Let's do in backward. I want to do in the opposite direction of the problem because I would like you understand very well this idea. And after we are doing in opposite direction. So forward and backward. Suppose we have two fractions. This is the motivation example. No, number one. Number one is motivation example. In the motivation example, we have, for example, two rational function, but by the way, they are in the typical format of the partial fraction. Degree 0 in the numerator, degree 1 in the numerator. I want to condensing this and this together, boom, and only one. So now it's easy, it's super easy. Least common denominator of this, and between this and this, you take both. So x plus 4 multiply x minus 3. And you multiply no. You divide this guy by each denominator one by one. This is the intermediate element. And multiply by the corresponding numerator. Let's do it quickly. When you divide the LCD divided by denominator 1, es obvio que x plus 4 is cancelled. And stay alive x minus 3 times 3. 3 times x minus 3. Plus, this plus is this plus. When you divide LCD divided by denominator 2, it's obvious, I'm using another color, the x minus 3 is cancelled and stay alive x plus 4 times 2, so 2 times x plus 4. Now multiplication. Distribute the property and combine later. So our function is x plus 4, x minus 3. You apply distributed 3x minus 9, 3 times 3 is 9, plus 2x plus 8, no? Okay. Now we combine later 3x plus 2x is 5x, and negative 9 and positive 8 is negative 1. Boom. And this is the rational function. And we now learn how we decompose this rational function into partial fraction. So we are doing now in opposite direction. I want to illustrate this idea because do you see the idea that everything is, we are doing well, but I want to explain backward. I explain using two different ways. There are many ways, but I want to explain two different ways. The long way and the short way. What is the reason that you don't explain only the short way? Because some problem is impossible doing by the shortcut, and sometimes we need to do for the long way. So now example 1 is the same example, but we are doing in opposite direction. Suppose that I am doing in the test this partial fraction, and the goal is decompose and partial fraction decomposition. The first thing you should do is factorization each polynomial. And this is super easy. Is 4 and 3, because 4 times 3 is 12, and 4 minus 3 or plus 3 minus 3 in this case 1, and the sign are positive 4 and negative 3. Done. After, my goal in calculus 2 is decompose this into partial fraction. The first partial fraction is, suppose it doesn't matter the order, x plus 4 and x minus 3. And you don't know the number here, they put a and b. Normally you put constant A, B, C, D, E, F. Not too much. It's A, B, C, A, B, C, D. And now we are doing in this direction. Let me explain the long way. Bueno. The first of all, you find the least common denominator. So the least common denominator is x plus 4 times x minus 3. And you multiply everything by the LCD. When you are doing this multiplication, we have 5x minus 1. Because in the left-hand side, everything is cancelled. However, in the right-hand side, no. We have a times x minus 3 plus b times x plus 4. Do you follow me? Because, you know, in the right-hand side, in the first, cancel out this and this. In the second, well, in the second, cancel out this and this. Okay, now, this is an important moment. In this case, you have two possibilities. You apply this distributive property. Let's do it. X minus 1 is equal to ax minus 3a plus bx plus 4b. And you grouping somehow the term can contain x and the other can do not contain x. So x is common factor, a plus b plus 4b minus 3a. What? 3a. I make a mistake. Let's copy in the same order. Minus 3a plus 4. And we compare. Wow. Compare. Compare that polynomial in the right hand side and that polynomial in the left hand side. It's obvious. Okay, a plus b is 5. And it's obvious also that minus 3a plus 4b is equal -1. Right? And we have in that moment a linear system of equation 1, equation 2, and you, of course, you apply the method you know for solving linear system of equation, maybe elimination, maybe substitution. I don't know why in my paper, because I make a decision to say I make this decision. Maybe you are doing another decision. Every smart idea is good. For example, I multiply the equation 1 by 3. What is the intention? What was my intention? When you multiply this equation by 3, we have 3a plus 3b b equal 15. And it's my new equation 1, exactly the same as the original. However, it's ready for elimination. When you add in by column, the 3 is cancelled. This is 7b, and this is 14, no? Because 15 minus 1 is 14 divided by 7, b is 2. In order to find the a value, because we have a and b, no? Is, well, if you take the easier equation, in my opinion, is the original number 1, so a plus 2, because b is 2, is equal 5. Therefore, a is equal 5 minus 2 is 3. Okay, cool. A is 3 and b is 2. Who is a? Well, a was the hypothetical coefficient of the fraction, partial fraction that contain x plus 4. So this is 3. And b is the hypothetical partial fraction that contains x minus 3. Okay, 2. And when you compare the answer, it's exactly the same we are doing in the motivation example. Wow, but it look like too long at this, right? No. I want another way. Another way is not always possible apply. But when it's possible, you are doing this way that I want to explain. I know. Suppose that we are in this crucial moment. In this crucial moment. Yes, that moment. I copy again this moment. But I do not apply distributive. No. I take a smart value. What is a smart value? A smart value is the value that when you plug it in, give me 0 some factor. Suppose one smart value is at x equal 3. Yeah, I plug in 3 in this equation. 5 times 3 minus 1 should be 8, 3 minus 3. Wow, it's smart. Look at that. What is smart? Because you plug in 3 minus 3 is 0. Disappear that part. It's gone. Plus b 3 plus 4. 15 minus 1, 14. 3 plus 4 is 7b. It's obvious. Divided by 7 both sides. B. Wow, amazing. Too fast. We get the same result. Okay, well, another smart is -4. Because when you plug it in -4, here again, we have 5 times -4 minus 1 equal 8. I don't have idea who is 8. -4 minus 3 plus, it's obvious that b is gone. That part is 0 because -4 and +4. Just in case, let me copy. It's 0. This is the smart value. It's the value that when you plug it in, at least one factor disappears. Wow. So far we have 20, 20, 20, -20, -20, minus 1 is -21. Okay, and the right hand side we have 8 times -7 divided by -7 both sides. It's obvious that it's 3. Super cool. Everyone follow me? Complicated or easy? Easy. Partial fraction decomposition. It's very, very important in Calc 2. When you take Calc 2, I promise that you remember me because one operator, this is the name of the method that we use in Calculus 2. Apply partial fraction decomposition to create, for example, integral. Integral, you solve it by one method is called a partial fraction decomposition. Let's do one more example of this. Well, no, it's not easy. We have different cases. We are studying now the elementary case, case 1, is when you have in the denominator, we have linear factor. And so you have in the denominator irreducible quadratic, this is a little bit more complicated. Or when you have, for example, in the denominator, the multiplicity, no one. Okay, but now let's do it step by step. Okay, this is the case 1. We studied case 1. The previous example was case 1, in which you have the rational p divided by q, but q has only non-repeated real linear or linear. Let me go linear. Linear means no quadratic. Linear factors. Okay, this is the easy. Let's do one more of the easy. Suppose it's given this expression. My question say, well, decompose and partial fraction decomposition. Cool. Step number 1, factorization. Well, in the top, no. The top, we cannot do anything. And the bottom, yes. Is 3 and 2, I guess so. Because 3 times 2 is 6. And 3 plus 2 is 5, both negative, right? Okay. Now the format of the partial fraction decomposition is x minus 3, x minus 2, and it doesn't matter what you call A and B, it doesn't matter what you put first, x minus 3 or x minus 2. It's completely irrelevant. You get the same result because the mathematics is exact sign, but the guy you call A, you call different, is opposite, no? Swap. It's okay. Now let's do it using the smart value, no? Least common denominator, it's obvious. Okay, is x minus 3 times x minus 2, and you multiply this entire equation by LCD. It's obvious again, the left hand side we have only x because everything is gone. X minus 3 is cancelled, x minus 2 is cancelled. However, in the right hand side, no. We have a x minus 2 plus b x minus 3. Everyone follow me so far? Do you understand very well this? Oh. Okay, so you understand this, is the easy part. Now the selection for the smart value. Smart value, remember, is a value when you plug it in, some factors disappears. Suppose 3, x equal to 3. See, I create this intentionally. This guy is gone, and we have 3 is equal a 3 minus 2, and 3 minus 2 is 1. Therefore, a is 3. And immediately you replace here. A is 3. A is 3. Yeah. A is 3, no? A is 3. You replace here. 3. Okay. Now, in order to find b, exactly the same. You apply x equal 2, no? X equal 2. Entonces, in this case, when you substitute here, the part is gone, is this part, 0. And the part is stay alive, is this, 2 equal b, 2 minus 3, que es negative 1. Entonces, 2 is equal b times negative 1, es obvio que b es negative 2. Cool, negative 2b. You replay here 2, but where? I don't understand very well. Here, negative 2, yeah, you can. This is correct. Another possibility, another 2 is, no, I like this. You put a negative here, gets the same. You know, guys, when the fraction is negative, you put a negative in the top, and the bottom, or in the front. I don't care. The answer is the same. This is the case 1. The case 1, when you have non-repeated and linear factor. Super easy. Let me complicate a little bit your life. Suppose now, case 2. Well, case 2 is when you have, so again, p divided by q, but q has repeated. Repeated linear factor. No quadratic, linear, but repeated. One example of this is, suppose that function is given in the test, x squared divided by x minus 1 squared, time, factorization, time, x plus 1. Suppose this. When you want to decompose in partial fraction decomposition, you decompose 3. Okay, the guy have multiplicity to, actually this is x minus 1 times x minus 1, right? That means this factor x minus 1 have multiplicity 2. So when this situation happens, don't ask me why, because it's a little bit complicated to prove mathematically. But you following my instruction. You break it down, x minus 1 square again, and x minus 1 without a square. Okay, is x minus 1, not necessarily parentheses when the exponent is 1. Suppose you have complicated 1 x minus 1 cubic. So you have x minus 1 cubic, another partial fraction x minus 1 square, and another partial fraction x minus 1 to the 1. That you decompose, when it's repeated, you decrease in this point. See, in this case, get 2, 2, and 1. And we have another linear, que es x plus 1. End the story. Yeah, I call the coefficients ABC. Okay. Now LCD in that case is, let me copy it here, LCD is exactly x minus 1 squared, x plus 1. When you multiply this time, this expression one by one, in order to doesn't affect, we have just x squared, nice, equal a times x plus 1. You know, stay, the factor gets missing in the expression. Entonces b, x minus 1 times x plus 1. Because at least cancel 1. And plus c multiplication by x minus 1 squared. Let me copy more clear. X minus 1. Everyone follow me, guys? It's easy or not? So when you multiply LCD by the first one, it's obvious. Let me use in color. It is cancel. And stay only x plus 1. Okay, multiply by numerator. When you multiply the second, it's obvious que cancel out. I was the dew of the heavy rain. Okay. No, everything happened. The heavy rain interfered the communication. Yeah. Well, remember, see, you try to see the lecture, it's okay. See, you don't, you see, and you do, no? So we need to take advantage of any technology. So and you do. Or you stay here. When you multiply by the second, it's obvious que it's cancel at least one of these and one, and stay alive only one x minus 1. There is a reason that we have x minus 1, x plus 1. No, sorry, x plus 1 stay. Let me copy. This is x minus 1 squared, x plus 1. Entonces we cancel out one of these or one of that. Stay x minus 1, x plus 1. And finally, exactly the same. Yes, Sergio Medina dice yes. X minus 1 squared, x plus 1 is obvious que this is cancel and stay only x minus 1 squared. Cool. So now in this moment, I recommend doing exactly the same idea, smart value. And the smart value are, for example, x equals 1. Because I know that when you plug in 1 here, 1 minus 1 is 0, 1 minus 1 is 0. Entonces 1 squared, que es obvio que es 1, a times 1 plus 1, and the rest is 0 and 0, because 1 minus 1 is 0. Cool. 1 squared is 1, 1 plus 1 is 2, therefore a is 1/2. Right? And when you write in the partial fraction decomposition, some people prefer put it here 1/2 here because of the a value. Another people no. Another people prefer put a 1 in the top and the 2 in the bottom, que es equivalent, you know? I like this, but it doesn't matter. It's the same. Okay, let's continue with the B and C. Suppose now que hay substitution, another small value que es x equal negative 1. So you get that gone. The negative 1 plus 1 is 0. And this part is also gone. Negative 1 is 0. And here, no. So we have negative 1 squared plugging in here in the right hand side. Negative 1 squared positive 1. It's obvious, right? And C, and here we have negative 1 and negative 1 squared. This is a 1 positive. This is negative 1, negative 1, negative 2, and negative 2 squares is 4. So for C, therefore C is 1 over 4. C is 1 over 4, following the same idea, you put a fraction like that, 1 parenthesis 4, or 1 4 are in the top, either way. But the thing I try to illustrate in this example is that we using two smart values, 1 and negative 1. However, we need to find B, and we have no more smart value. Remember, smart value by definition is the value that are doing at least 1 factor 0. That is the reason this is smart, because simplify our equation. So now I'm using good value, no smart. Good is good. Good value, que es arbitrary value, because I take advantage, I know A and B, A and C, sorry. Now you find B. And I like so much like a good value x equals 0 because it's easy. This is easy. C equals 0 is easy. So now plugging in 0 here. Again, in the original equation, 0 squared is equal 1/2, que es A, 0 plus 1. Plus B, que I have no idea, 0 minus 1, 0 plus 1, plus C, que es 1 over 4, 1/4, 0 minus 1 squared. Simplification. This is 0. This is 1/2, because 0 plus 1 is 1. 1 times any number is the same number. And B is, this is negative 1, and this is positive 1. And together is negative B. No positive B. Negative B. Plus 0 minus 1 is negative 1. Negative 1 squared positive 1 is 1 over 4. Okay, cool. Therefore, I solve for B. And B, I put in the right hand side and move B, so we have 1/2 plus 1 over 4. Least common denominator, obviously, is 4. 4 divided by 2 is 2 times 1 is 2, 2 over 4, and 1 is 3 over 4. Wow, B is 3 over 4. Now 3 over 4, 3 over 4, 3 over 4, 3 over 4. Therefore, our partial fraction decomposition, when I finish, you copy 3 over 4 here. Look, no B anymore. It's 3 parenthesis 4. What is my final answer? Let me copy because it's not clear. This rational function, by the way, is proper because the degree of the numerator is 2. However, the degree of the denominator is 3, 2 plus 1, is equal 1 over 2 x minus 1 squared plus 3 over 4 parentheses x minus 1 plus 1 over 4 parentheses x plus 1. Boom. And this is completely equivalent algebraically. Entonces en calculus 2, the integration, que is the operator of the calculus, que you don't know now, of course. If you like one symbol like that, integral, when you apply the integral here, it's super complicated. However, when you apply the integral step by step, it's super easy. This is the method, partial fraction decomposition method in calculus 2. Clear? Clear? Cool. Excellent. Okay, so I want to complicate more because I need to explain the 4 possibilities. So far we study linear non-repeated. Cool, easy. We study linear, when you talk about linear, it's degree 1. Linear repeated. Ooh, it's a little bit more complicated. And now non-linear, so irreducible quadrant. So the case 3 is P divided by Q, but Q is the denominator polynomial, no? Contains a non-repeated, pero irreducible quadrant. Irreducible quadratic factors. Maybe 1, maybe 2, maybe 3 factors. Look, suppose this example. 3x minus 5 divided by x cubed minus 1. Oh, whoa, what the hell? I don't know. Okay, let me try to do my best. First of all, step 0 to start any problem. This is factorization. Factorization the denominator. The numerator, no, because the numerator in this case is impossible. Pero bueno, in general, both numerator and denominator. But in this case, you need to remember this formula, intermediate algebra. A cubed minus b cubed is equal a minus b, a squared plus ab plus b squared. This formula is called in the intermediate algebra differences of cubes. So when you factorization difference of q, you obtain one binomial and one trinomial. And this trinomial, professor, is not possible break it down into binomial like in the regular factorization. The answer is no. And the reason is no is because the solution of this trinomial is always complex or imaginary. That is a reason in the real field, boom, leave it like that, don't touch. Okay, let's see in detail now. Following the formula, I know that this binomial is special. We break it down into parentheses. The first parenthesis is the binomial, which is a cubic root, so the cubic root of x cubed is x, and the cubic root of 1 is always 1. No? This is x minus 1. Look, exactly the same prediction of the formula. This is that part. Now, in the trinomial part, is square the first, to the first is x squared, plus multiplication both. Multiplication 1 and x is just x, because 1 is invisible. Multiply. Plus 1 squared. 1 squared. I suppose you remember that, right? Yes or no? Yes, Sergio Medina is yes, I remember intermediate algebra, 1033. Okay, you say, professor, you don't need to explain this. However, how to feel comfortable, to feel a little bit comfortable with this factorization, one on the top, I copy exactly the same. I don't change anything. To feel comfortable, just in case I want to check in this triangle, x squared plus x plus 1. So the professor explained me that when the solution of this is complex, it's impossible factorization and the real field. Okay, so one fantastic way to determine this is using discriminant d, is b squared minus 4ac. Okay, in this case, a is 1 in the quadratic equation, no? B is 1 and c is 1. Everything is 1. 1. So when you compare discriminant, is 1 squared minus 4 times 1 is equal 1 squared is 1 and 4 multiplication by 1 multiplication by 1 is negative 4 and 1 minus 4 is negative 3. Wow! And this, when the discriminant is negative, indicate also that the solution of this trinomial is complex or imaginary. In this case, it's complex. So has real part and imaginary part. But in the real field, we cannot factorization like a factor of the degree 1, no, linear, no. So you leave it like that. It's quadratic irreducible. It's the technical name of this guy. The technical name of this guy is irreducible quadratic. In this case, not repeated because we have no exponent 2, exponent 3, exponent 4. Yeah? Nice. I like that. I appreciate so much. Okay, because the most complicated scenario is that you have irreducible quadratic and also multiplicity. Wow, what the hell? I don't know how you solve that. Okay, let's continue. Well, so now I feel more comfortable to understanding that part of the reducible. Okay, now you separate into factors. One factor que is linear factor, and we have 0 degree. One number, A. Another factor que is quadratic irreducible. When this equation happens, in the top we have linear, bx plus. This is the typical format for the partial fraction decomposition. Si es linear, en the denominator es 0 degree, o sea, just a number, en the numerator. Si es quadratic irreducible, bueno, entonces now the partial fraction is linear, the numerator. Cool. Entonces in this case, I multiply one more time by the least common denominator. The least common denominator, this example is, for sure, x minus 1 times x squared plus x plus 1. Okay, cool. Then you multiply everything, including this, not the original, by the LCD. So we have 3x minus 5 is equal 8 x squared plus x plus 1 plus b x plus c, parenthesis, very important, multiplied by x minus. Okay, good. Now, instead of using smart value and good value, no, you can, of course you can, but I recommend doing by the traditional way. You factorization, so you have 3x minus 5 is equal 8x squared plus ax plus 8. I will distribute here. And you FOIL here is bx squared minus bx plus cx minus. So you grouping the same degree, the same, you know, x squared, we have a plus b. Okay, this guy, let me use a different color to emphasize this guy and this guy together. Now, in the x part is this and this and this. Okay, so now we have plus x, a plus b, a plus b, a ver, a minus b, sorry, minus b plus c, no? And finally we have the independent que no contain x. Let me use another color, maybe blue. This guy and this guy is a minus c plus a minus c. And you compare this polynomial and this polynomial. It's obvious that a plus b must be 0 because we have no x squared, 0 x squared here. Likewise, at least we have in my hand one equation. Another equation that I have in my hand is a minus b plus c equal 3, no? A minus b plus c equal 3. Equation 2, because I suppose that this is equal to that. And finally, a minus c equal negative 5. Equation 3. Entonces, in this moment, we have a tedious system of equation. Okay, we can do it in that way, but no. I illustrate that sometimes good, sometimes not good. So you complicate your life because you have 3 equations. It's no big deal. It's doable. However, I don't like this. Let's do it by the traditional way of the smart value. Or at least we have only one smart value. What is the smart? Only one smart value that we have in that problem, x equal 1. Because when you create x equal 1, look at what happened here. X, 1 minus 1 is 0. Disappear that part. Entonces, 3, I'm plugging it here. 3 times 1 minus 5 is equal 8. 1 squared plus 1 plus 1. And that part is gone. Because 1 minus 1 is 0. Smart value. Okay, good. I like this one. However, 3 minus 5 is negative 2. And 1 squared plus 1 plus 1 is 3. This is 3a. Therefore, a is divided by 3 both sides. A is negative 2/3. Ooh. Entonces, why use a combination of the idea now? Because if A is negative 2/3 and together A and B is 0, it's because B is positive 2/3. So the opposite sign. If the only possibility together, addition, give me 0. I like that. Why not? We have a smart value. No, unfortunately, no. We have no smart value. So now, in order to find the C value, maybe you take the equation 3, and equation 3 is 8 is negative 2/3 minus C is equal to negative 5. Wow, easy. So negative 2/3 plus 5, move 5 to the left, and move C to the right, and you find the LCD get 3 and minus 2 plus 15. So 13 order. Cool, I like this. But it's positive or negative? Let me see. It's positive or negative? A minus C, negative 5, it's positive, yeah, it's positive. C is 13 order. So what is my final answer, guys? Well, my final answer is go at the beginning. The expression is given is 3x minus 5 divided by x cubic minus 1 is equal negative 2 over 3 x minus 1 plus b, que es 2 over 3 2/3 x squared plus x plus 1, and here I forgot x, is this x, look, this x, and you can separate, yeah, you can, because we have the same denominator, look, is x squared plus x plus 1, we have 3 here, it's the same, and here we have c, is 13. No, so we can put together, why not? Put together like that. 3x squared plus x plus 1, and you put 2x plus 30. And here the rest is the same. Minus 2 over 3x plus 30. And this is proof. This is my final answer. Do you hear the rain? It's raining heavy here in my house. Yes, well, but do you hear well, or I need to increase the... A ver, speak. Do you hear me well? The problem is that I am working now using laptop. I have one laptop and another computer, and the computer is too hard switching to another. Yes, we hear it, Professor. Okay. I hope the raining is stopped. No, it's stopped, but si it's raining not heavy, doesn't affect. I hear you. Good, Sebastian. Okay, one more example of the complicated, is when you have the case 4. Case 4 is when you have Q contain Repeated. Wow. Repeated. Repeated what? Repeated irreducible. Irreducible quadratic factor. Quadratic factor. This is the most complicated scenario. I promise in the test I never put this case. This is too long. Guys, there are problems que algebraically super complicated, and you spend actually 1 week doing that. And so you make a mistake in one stupid signs, you screw up everything. So therefore, in your moment, I promise, I want to explain another way to do this, or at least not to do, so do double checking that your answer is okay using software, special software that they are online. Okay? Okay? So don't frustrate because it's no, Emily, this is no big deal. This is not complicated. However, it's too long. So the thing is too long. Everyone, including me, because I'm no superhero, we can make a mistake. And one step, one sign you change, yeah, you change everything. Suppose this. Es obvio que the factor x squared plus 4 es irreducible quadratic. Irreducible quadratic. But in this case, quadratic. In this case, is raised to the second power. This is repeated and irreducible quadratic. Okay, sorry. So what should I do? You decompose. How you decompose? You decompose like that. In this case, in 2. Why in 2? Because you copy x squared plus 4 squared, and you copy here x squared plus 4. In this case, you decreasing the exponent. See, this is 2, this is 1. And 1, you know, is invisible. Well, so we have ax plus b and cx plus b. I call in my paper in this way. Suppose that you on your paper you call ax plus b and you call cx plus d. It's okay, either way. But in this moment, when I create my lecture in the paper, well, I did it that way. No? The least common denominator obviously is LCD is x squared plus 4 squared. Because the rule of the least common denominator is you take every factor. However, when the one factor have multiplicity 2, 3, 4, 5, you take the majority of the multiplicity, in this case 2. And when you multiply everything by LCD, we have x cubic plus x squared is equal cx plus d, because by coincidence this is equal to this and equal to this, plus ax plus b times x squared plus something like that. Okay. So my recommendation is no smart value. It's no smart value because this is a reducible quadratic. I know that the solution of this polynomial, the 0, is irrational, complex or imaginary. So have no sense to talk about smart value. The smart value is imaginary. No good. I don't like plugging in I here. You can, but it's not good. So now let's do it by the traditional way. The traditional way is, well, this is cx plus d, no problem. You foil now here, and you have a x cubic, multiplication this and this is plus 4ax multiplication of this and this is bx squared. And finally, 4b. This is a square. Okay, now you group it. X cubed plus x squared is equal. Let me try. The cubic, we have only one guy. Okay, it's 8x cubed. The square one, okay, we have only one guy, que es b. And the rest is well, the linear. The linear is this and this. You factorization x, so es x is c plus 4a. And finally the term that do not have x is d plus 4b. Okay, good. Now we compare that polynomial and that polynomial. That polynomial, look, that polynomial. It's obvious, look at that, compare term by term. A1, here one, B1, and the rest is C plus 4A is 0. Because on the left hand side we have no 0x and no 0 independent without x. So we have two equations, that C plus 4A equals 0 and B plus 4B equals 0. But this is super easy because I know that A1 substitution in this equation, C plus 4 times 1 is 0, therefore C is equal negative. Likewise, similar, D is equal 4 times 1 equal to 0, D is negative. Okay, so what is my final answer? Well, my final answer is, okay, x cubed plus x squared divided by x squared plus 4. This is the case, remember, in which you have repeated irreducible. Irreducible is when it's complex 0, and repeated is when you have exponent 2, exponent 3, exponent 4. And I discovered that this is equal a s1 b s1, this is x plus 1 divided by x squared plus 4. Okay, that part. When you replace a and b like a 1, b. And negative 4 is like a plus negative 4x minus 4, no? Because b and c are negative 4. That's a coincidence. And this is x squared plus 4 squared. You can leave it like that, you can. This is okay. However, in calculus 2, some people prefer factorization negative 4. You put negative 4 out, and you have x plus 1, x squared plus 4 squared. And this will look like beauty and cool. Cool. No problem. Let's move on to the another super easy and important topic. It is the system. Again, system professor, system of equation, but in this case, non-linear. System of non-linear. Non-linear equations in 2D. I don't know if we have time to go with 3D. 3D is not important. Well, it's important, but not extremely important. The student can need to take calculus 2. 3D is calculus 3. Okay. Definition. What is that? Suppose we have this system of equations. Minus x minus 7y equals 50. Equation 1. And x squared plus y squared equal 100. Equation 2. And this is my system. Que contain two equations and two unknown. Es x and y. Es obvio que the equation number 1 is linear. Remember, one more time, repeat the idea. Linear means exponent 1. When this situation happens, this is in 2 dimensions, it's a line, or in 3 dimensions, it's a plane, it's flat. When it's non-linear, the second equation is non-linear. Non-linear. Obviously, this is no line, it's a curve. In this case, a circle. But the center is in the origin and the radius 10. It's non-linear. Let me copy this idea clear. Non-linear. Non-linear is when the coefficient is not 1, it's 2, 3, 4, 5. And obviously this represents in 2 dimensions a curve. The linear represents in 2 dimensions a line. In 3 dimensions, well, let's see 3 dimensions. It's not important 3 dimensions now. Okay, entonces now at least one equation que es non-linear, the classification of the system is already non-linear. See, at least one. See, both are non-linear. Whoa, much better, more clear. It's non-linear system. This is suppose another example. 2x squared plus y squared equals 17. Equation 1. And now x squared plus 2y squared equals 22. Equation 2. Suppose que given this system and the equation is solving the system, so now you immediately see, wow. This equation is non-linear. And this equation is also non-linear. Therefore, our system is obvious as non-linear. This concept is clear. Entonces, what is the particular idea for non-linear? Number one problem is that there are no specific way for solving this. No. You know, linear is super easy. Linear, you apply substitution, elimination. In non-linear, there are no specific strategy.
Professor, you are muted.
Yeah. Now you hear me now?
Yes.
Wow, amazing. Raining, I put a mute. I put a mute because I explained, I don't know if I explained this class or another class. In my pen, I have a button. Accidentally, I pressed that button to put a mute. Let me check it just again. No, okay. Then we have two possibilities, three scenarios. Suppose that the first equation represents a circle. And the second equation represents a line. And thus we have two solutions. This solution and this solution. And you see example right now, in few seconds of this. In this case, you have two solutions. Suppose another scenarios. Suppose that we have something like that, que es ellipse. The problem is in your moment, we study, no circle. Ellipse, like that. The problem is that our whiteboard fixes it like a circle. Let me incomplete. Good. And we have another ellipse, like that. Beauty. Now we have 1, 2, 3, and 4 solutions. Wow, 4 solutions. It's another scenario, another possibility we're discussing right now. And suppose another scenario that we have a parabola like that, parabola, and we have a circle like that. In this case, never touch this curve, therefore we have no solution. Okay, so now we have different scenarios. Okay, you never see in linear system. In linear system, we have one solution, no solution, or infinity many solution. In this case, it's very, very weird. It's infinity many solution, but you have more than one solution. Okay, let's do it. One first example. Example 1. Suppose this is minus x minus 7y equal 50. Equation 1. Let me make it zoom. And x squared plus y squared equal 100. Equation 2. I solve it immediately. I realize, wow, the first equation is linear. The second equation is non-linear, professor. Okay. When this situation happens, the most convenient idea is apply substitution. How? You solving any variable. Okay, remember substitution is good. When the one coefficient is 1 or -1, so I take advantage that this guy is -1, and you solve for x. So solve for x is, when on minus x, I move, okay, 50 stay here, and plus 7y, right? I move 7y negative to the right hand side like a positive, and multiply both sides by -1, multiplication by -1, because I want no negative x, I want positive x. So positive x is equal minus 50 minus 7. Cool. Now, substitution. You substitute this expression where? In another equation, in the x place here. Okay, let's do it. Entonces, minus 50 minus 7y squared, like open the parentheses, plus y squared equal 100. Okay, at least I have in this equation only one variable. This is nice. And you can see, okay, look, this negative and this negative inside the one parenthesis square, you can convert like a 50 plus 7y. Yes or no? Square plus y square equal 100. What is the reason? The reason is actually this is like a -1 times 50 plus 7y, no? So you square both sides. -1 squared is +1, and +1 is invisible. So now there are no reason to clarify this. Only you immediately you see a square and everything is negative inside the parentheses, decompose. And you now foil this binomial. Oh, you remember the quick foil. Okay, the quick foil is you factorization. This is okay. Let me copy in that way. 7y plus 50 squared plus y squared equal 100. Okay, ready to quick foil. Quick foil is square the first, and square the first is 49 y squared. Okay, guys, let me recall something. Recall. Look, when you have a plus b, and you square. Of course, you can do like a kindergarten guy, a plus b times z, no? And you FOIL. But the quick FOIL is different, and you save time. So you know that a squared plus b squared is square the first plus twice multiplication both plus square the second. It's easy. This is the formula. Either way, guys, you don't remember this, no problem for me. You copy like a kindergarten, 7y plus 50 2 times, and you FOIL. First, outer, inner, last. However, I don't like this way. No. I lie, I accept. But when I do it in my hand, we are doing use the formula because I know that this is quick FOIL, and quick FOIL is square first plus multiplication 50 and 7 get 350, but multiplication by 2, additional 2, because they are two in brother. When you FOIL combine, you say 700. 700y. Do you understand where I come from 700? So you multiply 7y times 50 times additional 2. Where I come from this additional 2? This additional 2 is this. So it's 700y plus square the second 50 squared 2500 plus y squared equal 100. Okay, this will look like, in my opinion, quadratic equation. But let me try to manipulate in the efficiency way. Well, first of all, I realize that 49 and 1 is 50. 700y plus 2500 minus 100 equal to 0, because I want to express the equation in standard. So it's 50 y squared plus 700 y plus 2400 equal to 0, because 2500 minus 100 is 2400. Cool. However, in this moment, I saw that you can divide this equation by 50. So you try what is the greater common factor in between 50, 700, and 2400. I discovered that 50. You divide by 50, you divide by 50, everything, 50, 50, 50. Suppose that you don't see that, no problem. So now you plug in this huge number in the quadratic equation. And this is more complicated, but you get the sense. However, now this is y squared plus 700 divided by 50 is 14. 2400 divided by 50 is 14. And we get this quadratic equation. Wow, it's super easy. The solution by factorization. By factorization is yy, and the combination is obvious, 8 and 6. Because 8 times 6 is 48, and 8 plus 6 is 40. Plus. Okay, so y is plus a is 0. Y is negative 8. And y plus 6 is equal to 0. Y is equal to negative 6. Cool. Now I have two values of y. Now the prediction is okay, the solution is 2 points. But I need to find the x value associated with this area. And remember, we come back at the beginning. At the beginning, we are using these. Okay, I'm using at the beginning for the substitution, right? So remember, is at y equal negative 8 logarithm 3. X is equal negative 50. Be careful with the signs. minus 7 times negative 8. Therefore, it's a minus 50 plus double negative 56. That's 36. And the point is the point 6, negative 8. This is my first. My second point is add y equal negative 6. You remember, here we have two y values. Logging in here, x equal minus 15 minus 7 times negative 6. Therefore, x is equal to minus 50 plus 42 is negative. And the answer is negative 6, negative. So what is the solution, Professor? Solution set. Solution set of this system nonlinear. There's 2 points. The first point is negative 8. Negative 8, no. 6, 6, 6, negative 8, and negative 6, negative 8. I mean, I make a mistake or no? 6, negative 8, and, beautiful. Look at this. Just in case, guys, don't be scared. You say, too long. No, it's long because, you know, algebraically, you need to substitution, manipulate something, foil or quifoil, either way, and you ending finally in the quadratic equation, no problem. Now, one fantastic way, you finish, but you want to get 100 points in the test, and you don't know if your answer is correct or incorrect. Why don't you go to Decimals? You go to Decimals. Let's do it now. Decimals now. Okay. Let me share. Decimals. System only language. Boom. Do you see Decimals? X is equal to negative 8. Shouldn't. Is negative. So the solution is negative 8. Okay, let me come back again to see. Solution was, yeah, right. You are right. Yes, so, thank you. Okay, the solution, it was negative 8, negative 6. Negative 8, negative 6. Okay, you are right. So the solution is 6, negative 8 is okay. And the second is negative 8, negative 6. Okay. Just in case, now verification of decimals. Do you see decimals? Do you see? Yes. Let's see example 1. Example 1. Boom. Example 1, guys. Look. I copied the equation. Okay, the equation was linear. It's a blue line. And the other was a circle. Circle with the radius 10 and the center and the origin 0.0. And the intersection between this curve, give me the point. The orange point, negative 8, negative 6. And the purple color point, positive 6, negative. Boom. I double checking my work. Graphic. Super cool. Emily said yes. Okay, so now I come back. I come back to my whiteboard. Yeah, I fix it a little bit. The answer that I copy wrong, okay, is, look, I fix it. So the answer, this is X value. This is X value. So I copy here. And this corresponds with this Y value. I make a mistake in the last one. And Y negative 8 This guy is this. And the answer was x equals 6 is this. Now I am right. Let's do it on one more problem. Non-linear system I am doing, guys. Non-linear system of equation. Okay. In this case, a little bit more interesting and complicated is 2x, example 2x plus y linear equation equal 5 linear, x squared plus y squared equal 50, non-linear equation. One linear and one non-linear. And when this equation happens, always you take the linear and you apply substitution with the variable that has coefficients 1 or negative 1. Immediately you say y is equal to 5 minus 2x. And you take this expression and substitute it in a y place, in another equation, here, over there. So far we have done x squared plus parentheses 5 minus 2x squared equal 50. Okay, you focusing in the solution of this equation that is supposed to be ending in quadratic equation. Now you FOIL or quifoil. Quifoil is good for me. X squared plus 5 squared 25. Minus, because it's minus in between. It's a plus, but it's a minus. And the second sign is always positive. Multiplication both. 5 times 2 gets 10. 10 extra 2 is 20. 20x plus square the second, que is plus 4 x squared. Okay, minus 50 equals 0. I put equal to 0 on the right hand side because I know that we finished in quadratic equation. We combine like that. Who's like this and this? 1 and 4, F5. Minus 20. Minus 25. Because 25 positive minus 50 equals 0. Wow, if you divide by 5 this equation, the entire equation by 5. By 5, by 5, by 5, by 5. This equation now is x squared minus 4x minus 5 equals 0. Wow, too easy. Solving by factorization. Well, you open two parentheses. The combination obviously is 5 and 1, because 5 times 1 is 5, and 5 minus 1 is 4, and the sign are negative 5 and positive 1. The first solution is x equal 5, and the second solution is x equal negative 1. And now I go back at the beginning. I know that the connection, the formula is that formula. Entonces add x equal 5, y is equal 5 minus 2 times 5 is 5 minus 10 and negative 5. And the point would be the point 5 comma negative 5. Add x equal negative 1, y is equal 5 minus, be careful with the signs, 2 times negative 1. Entonces 5 plus 2 is 7. And the point would be negative 1,7. The solution set is 2 point again, is the point 5 comma negative 5 and negative 1,7. And with verification, one in decimals, why not? Why not? Everyone fine with the algebra? In this example, yeah, you understand much better the algebra? Okay, yes, the algebra is okay. Let me get the end business. Yes, thank you. Okay. Yes. Not shaded in this because I like double. Make sure and my solution is okay. Let me share the screen with the Desmos. Which Desmos system of equation. Okay. Okay. This is what one. It's a history. Example now is linear equation again. Look, linear and circle again is the circle, the center 0,0. However, the radius is square root. Fíjate que es decimal. Solution is -1. We say 1,7 is this orange point. And the other solution is 5,-5, que is this green point. Cool? So always, you lost in the algebra and verification in Desmos. See everything is okay, we have 100 points. Okay? Any questions so far? We are doing non-linear system of equations. No question. Okay. We come back again to do at least one more example. We continue next time. Okay. This is too easy also. Number 3 example is super easy. Let me verify if I share the whiteboard or not. See whiteboard. Do you see whiteboard now? Yes. Okay, cool. One more, guys. One more easy. And we solve it in the next time 3 more complicated. Suppose this equation is weird. Is example 3 is x minus 5 squared plus y squared equal to 25. Wow. Equation number 1. Let's solve because non-linear. And the second equation is y equal 3 square root x minus 8. Equation number 2. I don't expect in the test or in the homework online the system is giving is nice equation and this is organized equation. No, this is crazy. And you organize according to the way that you want to manipulate. No? But in this case, I can see that this is also circle. Look, this is circle. This is circle. Of course, it's non-linear. No? It's a circle. The center is located in the point 0,5. So 1, 2, 3, 4, 5 here. Okay, and comma 0. And the radius, I have no idea. Is I don't know. I have idea. The radius 5. It's a circle. It's different to the other circle that we see before. The center is in the 0,0, but in this case, it's the point. Remember, the equation of the circle is x minus h squared plus y minus k squared equal r squared. R squared, R represents radius, and the center is located at the point h, comma k. H in our example 5. K in our example is 0. That is the reason that the center is. Okay, this is clear, and this is a parabola. Parabola. Okay, I am not familiar, professor, with the parabola. Okay, no problem. Don't worry for this. We see in Decomposition the parabola, and in the chapter 4, we discussing in detail parabola. Okay, so now, so far it's okay. Let's move into the algebra. It's obvious that the best way is taking the equation 2 because y is already isolated. Wow. So I take advantage of this. I take this expression and substitution this package here. in the y place of the another equation. So far, my equation is reduced like that. X minus 5 a squared plus parenthesis 3 square root x minus 8 a squared equal 24. Not bad. Not bad. Not bad. And here you square. But this is a binomial. And you apply with foil or foil, either way. It's x squared minus 10x plus 24. Plus, in this case, no binomial. Because it's, it's monomial because the square root working in that case like a grouping symbol. So there are several grouping symbols in mathematics, parentheses, bracket, but it's also square root. So the expression inside you manipulate similar to this. Absolute value is another grouping symbol. In this case, it's a new square separately, 3 squared, and square root x minus a squared. Like that. Equal 24. This is x squared minus 10x plus 25. And it's a 9. Wow. And it's disappear because the square root and square cancel out each other. But don't forget to put the parentheses because you eliminate the radical, and the radical is considered like a grouping symbol. So you omit this parenthesis, you are in big trouble because you are supposed can I multiply only x? No, multiply everything. Now let me manipulate this equation. X squared minus 10x plus 25 plus 9x minus 72 minus 25 equals 0. I put right hand side 0 because I'm supposed to use ending in quadratic equation. So x squared, let me combine. This and this is my term. Negative 10 and positive 9 is negative x. Okay, cool. And this 25 cancel out and stay alive 72. Because, wow, it's easy. Because when you factorization, or suppose that you don't like factorization, no problem that you apply quadratic formula, and that's it. In this case, I see it's clear, it's 9 and 8. Because 9 times 8 is 72, and 9 minus 8 is negative. The sign is negative and positive. Therefore, the solution is 9 and negative. Cool. And we come back to find the y value associated with this 9 and negative 8. We come back to the expression for the y. Is this? So at x equal 9, y is equal 3 times square root 9 minus 8. 9 minus 8 is 1. Square root 1 is 1. And 1 times 3 is 3. Therefore, my famous solution point is the point 9, 2. Cool. Let's see what happens at x equal minus 8. The formula is the same. Y is equal to 3 times square root negative 8 and negative. Wow. We have 3 times square root negative 16. And this is imaginary, it gets 4i, and the answer is 12i. And when you in algebra, you obtain imaginary or complete, that means that the point that I'm looking for doesn't exist. So we have only one solution. The only solution that we have is the point 9, 9, only one, not two. Expecting one, but the problem is, remember, that was a circle here, over there, no good, and this is a parabola. But this is a half of parabola. And we have one solution, not two solutions. So you have the completed parabola, we have two solutions, but that part is no, it's missing because I take the positive square root. No plus or minus, no plus or minus, no plus or minus. So you put in the problem plus or minus, yes. Therefore, let's see in decimal, and that's it, guys. No more, because the rating is too heavy now. Okay. Let me share the screen with the decimals. Do you see decimals? Example 3. Look at that. Circle. Circle, we have center and the point 5,0. Radius 5. And this is the half of parabola. Look. And the solution is the intersection, the point 9,9. Okay, guys, nice. Stop here. Sorry, the rating. I wish you. Okay, stop sharing. Thank you, thank you. Thank you. Do you see my face now? Okay. Bye. Have a nice day, everyone.